All right. So that was how all the rules about removing, about adding them back. Let's think about how removing. And this is coming from what we were doing there is we wanted to prove something, right? So the prover was helping us prove them. Now it's different. We know something is true, and we want to remove the for all, so the oracle is going to help us, right? Now we're kind of doing oracle work, right? Suppose that I know for all G, right? Right? I don't know. That's a pretty statement. If it's true for all G, then it's true for all B. Can we go from one to the other? Well, you know, I have been cheating you guys by sometimes I let the letter tell you what the domain of the objects is, right? So you know Jeff means for all G means for all girls, and for all B means for all boys, right? But we don't do that here, right? In our formal world, right? In our formal world, there's one universe of objects, right? So if you say for all G, for all B, it means universally, right? So you can go from one to the other, right? Everybody see that? So, all right, so suppose we know for all X, and we want to conclude some weird thing, right? How do we do it? Well, this slide might have been made prior to oracles, right? I brought the oracles in later. So he's saying, hey, this is true. That means it's true for every X. I don't know what term represents, right? Here's some weird object term. It represents some object. I don't know which object it represents, but it doesn't matter because it's some object from our universe, right? Whichever object term represents, it's from our universe, and hence it's true for that object, right? Does that make sense? And from an oracle perspective, oracle perspective, good. We didn't lose our oracle, right? In our game, she's assuring you for all X. And how do we do that? What do we do when she's assuring us for all X? Where does the X come from? Yeah, it can come from the prover. It can come from the adversary. It can come from anywhere, right? Right? She's saying, hey, yeah, you give me Sam, it's true for Sam. You give me Fred, it's true for Fred, right? You give me term, it's true for term, right? So if somehow, somehow you prove the for all X, so now your oracle, you've proved it, so you have an oracle assuring you of it, then you can plug in, well, if it's true for all X, it's true for whatever object here I want to plug in, right? Does that make sense? Right? I can plug in Sam. I can plug in an arbitrary free variable X, right? Which is still a free variable, so it still means the kind of same thing, right? Now, so here, can we go from for all X to for all Y f of X? F of Y, can we go from this to this? Yeah, right? So, right, again, I don't know what object f of Y is. I don't know what Y is, so I don't know what f of Y is, right? But it's some object. So I can, when I rip off the for all, I can put any term in there I want, right? And now I have a free variable y, so I can put the for all back, right? People see that? And everybody kind of believes this, right? If it's true, if alpha is true for every object, then you give me any y and you map f maps to something, right? It's going to be true for that something, right? So I'm just going through some subtleties here to check how does it compare with our game, and right? Again, if we know that there exists an object, right? So how do we do it? We say if alpha is true for some object, then I can say let this be the name of that object, right? And in our oracle game, she's assuring us that there exists a y. So she says, I give you a y, and I assure you that it's true. Right? Everybody buy that? So in our formal proof, somehow we prove that there exists the y, and we can give it a name. Right? And why do we want to rip this exists off? Well, now it's a smaller thing without quantifiers, and we can do purple table with it. Right? Does that make sense? Right? It's notation. This is notation that I've added to the proof system. Right? It's saying, hey, this is a specific object. Right? You don't have to remember the context of where it came from. You can just say, hey, I write down that it's some specific object. Right? Now, more complex, suppose we've proved this already. The oracle's assuring us, right? So how do we play it? Well, she's saying it's true for every x, right? Oh, yeah. So here, what is it? She's saying for every x, so you can give, say, what about Sam, right? If for every x there exists the y, you say Sam, she says yes. She gives you Beth and assures you of it, right? That's the way the game was working, right? You give her a different object, she gives you a different y, right? So here, you say, what about this free variable x? Yeah, this free variable x has some y, but that y depends on the x, right? And so that's what we conclude from that, right? Does that make sense? Called the Skolem function, right? This, George kept telling me, what are you doing? You can't do that. And then later he told me, oh, actually, Mr. Skolem did it before me. All right, so here we have this. So what do? We get rid of the for all x and we make it a free variable, right? And now we want to get rid of this exists y, but we have a rule that says it has to depend on the free variable, right? And then remember what we meant. What it means is there exists some function y that works for every x. That's our understanding assumption. And here we got for every alpha, you give me any alpha, then there exists some function y that works for every x, right? That's where, right? Everybody kind of following this? Right? All right. So now suppose we prove that there exists one y that works for every x. Can we switch the quantifiers? Got to be nuanced here. Let's think about it. One way you can do it and one way you can't do it. So this says there is one y that works for every x, right? Right? So here I can remove the exists. There's one y that works for every x. And so I can bring in the free variable, right? And so that's okay, right? This says, what does this say? You give me any alpha, and then there exists a fixed y, right? A fixed y that works for every x, right? Here we're saying there exists a function of x that works for every x, right? Everybody see the difference there? And we all get it wrong, right? And so that's why we get it wrong. So do we rely on the rules or do we rely on our intuition? Well, both can. The rule, if you follow the rules correctly, they won't fail you. But you might not know which way to go, and you might forget how the rules go, right?